Okay, my dear students, today we're going to discuss about the acid plus carbonates. Okay, so first of all, you know very well about the acid like HCl, H2SO4. These are like acids, or HNO3. These all the types of acids. Okay, here we're going to see about an acid plus carbonate, what it gives you. So before to discuss the product, you should know what is a carbonate. Actually, that is your reactant. Okay, so here carbonate mean to say CO3. Understand? CO3 mean carbonate. It will attach with any part of the metal, but here like copper, Cu, CO3, copper carbonate, like here it's mentioned. So how the reaction going on? So first thing, what it's gonna tell you, this method can be used with any metal carbonate. As I told you, this carbonate is attached with any metal. So like here copper, that is a metal. And any acid like H2, SO4, H, NO3, these are acids. About reactants, these two reactants, if you have any question you can ask. Yani this reactant one, copper carbonate, or this acid like HCl, H2SO4, HNO3, you can ask. Then we go towards the products. Yes, please. Okay. Now,
Okay.
the typical experiment produce,
Cu is copper.
yes, copper. It's actually a metal, okay? Metal. Look here,
Oh,
what it's mentioned, it's a metal.
metal carbonate.
Providing the salt produced is soluble. A typical experiment produced is a similar to the carried out for an acid and a metal. Now, for example, copper to carbonate would be added in the excess of dilute nitric acid. This is the formula of HNO3 nitric acid. Effervescence, you know very well, like in the form of smoke or like in the form of any quickly it will coming like a bakhur that is coming out from there, would be observed due to production of carbon dioxide. Effervescence, you can say that as a gas. Okay, this
Oh,
gas is coming out, that shows you that is a carbon dioxide, CO2. Okay, as G is mentioned here, it is as a gas. Second thing you get here, a salt, that thing, and in the end you will get also water molecule. Yes, Mr. Musab, any question?
no, sir.
Okay, no problem. Look, the carbonate plus hydrogen ions, they give you carbon dioxide and water. Look, this is a carbonate ion. In carbonate ion, you have two things. One is oxygen atom and second is carbon dioxide. This oxygen atom go towards the hydrogen atom. Okay, and what it's make here water. Easy. And this carbon dioxide, when detached from one oxygen, it become a gas. So you can see here it's come in the form of carbon dioxide. Now it's easy. Now we can
Can you
go, yeah.
table the soluble basis, alkalis and insoluble basis?
Where on the same page or at the
The same table 8.3.
okay, yes, no problem. Look, first you understand the meaning of soluble. Soluble mean that can easily dissolve and you don't get the precipitate. Okay, yani solid particle. These are called soluble bases like sodium hydroxide, When you take this and you can add in water, you can get a solution. Okay, no precipitate. But in the case of iron oxide, they are give you insoluble bases. Base mean to say OH, OH, OH. Okay, so here you also have these type of insoluble bases. Now, Ahmad, easy? Okay.
Can you repeat again?
Yani, what is the meaning of base? First, it tells you that what is the meaning of soluble. That cannot make precipitate. That can dissolve. Okay, soluble. Like you add sugar in water, it can easily dissolve. You didn't find where is sugar. You dissolve NaCl, sodium chloride, salt in water. You didn't find. It is soluble. But if you see a precipitate like here, if you remember, no, down here, you can see here, like here, the precipitates, you can see here in this, yeah, this precipitate, these are coming. If you get these precipitate, it is mean that is insoluble. Okay.
Yes.
Okay, now go to the next. We already done this, we completed this one, and we also do the testing of all these carbonates and the testing of chloride. We already done, we
I
discussed
have
them.
another question.
Sorry.
I have another question in page 121.
One, 1 to 1.
Yeah.
This 1 to 4, 1 to 3, 1 to 2, and this 1 to 1. Yes, please. Where you wanna ask? Yes, please.
In the table 8.2.
Table 8.2. Here, no table 8.2 and 1 to 1.
Above first.
Yeah, okay. Oh, this very easy. Look, type of salts and acids they are formed from. Okay, listen. I tell you, Ahmad, the shirt you wear, it's from where? You say it's from made in Turkey. Okay, the Amro wear a shirt that is made from Germany or from USA. It's mean the main thing is shirt, yeah, that you wear. But the country from where it made, you write the name. In the same way, my dear, actually here, this is acid. Okay, here is acid. Here is acid. Now, what the salt that is attached with it, that is carbonic, that is ethanoic, that is hydrochloric, that is nitric, that is sulfuric. Why? When this is detached from acid, that gives you the salt of the same substance. Understand? Like here, hydrochloric acid, that is the formula of HCl. You know that this is a part in the acid that is give you H positive ion. And due to this, the acid is an acid. But here, when this Cl go towards any other like the metal, this one potassium, it make KCl. That is potassium chloride. This is the type of salt. So here chloride is a type of salt because chloride is attached with this acid. Here nitrate is the type of salt because why? It is attached with H ions. Now, Ahmad, easy? Yes, please. Understand?
Sir, in the example,
Yeah, all like this. Any example you can.
sodium and potassium.
Sorry?
The sodium and potassium are in the example.
Yeah,
Sodium
look.
carbonate and potassium chloride.
Yes, look. Potassium chloride, you understand, yeah? This
Yes.
is nitric acid. In the nitric acid, you have HNO3. It means this hydrogen will form due to nitrate. So this nitrate react with again potassium. So this K NO3, potassium nitrate. Okay, here you have sulfuric acid. Like here, you can say that H2SO4 plus sodium, like NaOH. Okay, so this detach from here and it will go from here. They both combine, they make water, and they both combine, they give you sodium salt of sulfate. So Na2SO4, that is your sodium sulfate, this one. And this H2O make H2O water. Now, Mr. Understand?
But yes, but I mean from where the sodium and potassium come.
Yeah,
Or
potassium.
the
Yes, I will tell you. For example, it tells when they react with metal. So then how they make a salt? You know that what is a salt, my dear? First, you should know that salt is a combination of a metal and a non-metal. Okay, like here, magnesium is a solid metal. Chlorine is a non-metal. When they combine, they make magnesium chloride. Okay. So this type of salt is depend upon the acid that is attached with it. Yes. Any other question?
No, sir.
Okay. And from any page, or I can go down.
Also, the hydrogen ions plus electrons
Okay,
means that
no. Listen, what's happening here? Look, it's mentioned 2H positive. What it's mean? Yani you have two hydrogen atom, 1, 1. It's also positive, also positive. Mean to say, this the hydrogen atom, this its nucleus. This one electron, it's lost. Now H become H positive ion. Okay, there is no electron. It's need one electron. But if here 2, so you write 2H positive. How many electron it need? It need 2 electrons. One electron come in this atom, yani this hydrogen. Second electron come in this atom. Okay, then they make a bond. How? H, that is equal to H2. So this form in a gas. So this is called H2 gas. It is a molecule of hydrogen. Okay.
Do not erase.
Sorry?
Do not erase this vitamin.
Do not? I don't understand. I can't get you. Please, can you repeat again?
Erase. Do not erase.
Raise?
Erase. Do not rub it.
This E electron. This E electron, this go into hydrogen back. First they lose, now they gain again, and they become a gas. So this gas is coming from here, and this is make with them as salt here. Yes. What will be the next, please? Amro with us? Okay, Alhamdulillah. Yes, now I can go down.
Yes.
Okay. So this thing is little bit remaining in the last lesson. So we're gonna see about them. Yeah, water of crystallization. So try to understand.
Remember, sir.
Sorry?
Remember in page 120 also.
Yahi, you tell me once why you make me go up and down. Page number what?
120.
And please speak complete, then mute your mic. You don't complete your words and you mute your mic and I just say what. Yeah, 120 what?
In after key definition.
This one?
120 key definition neutralization reaction.
Neutralization reaction. We done neutralization reaction many times. This?
Yes, yes, the H plus Q.
OH. This one? Key definition?
No, no,
Yeah, down?
down, down.
Okay, no problem.
It's equation.
Yeah, equation is very easy. Millions time I explain you this equation. For this, I'm going to take you on the board. So please try to understand from here. Look, my dear, this is NaOH. Okay, it is the molecule of sodium hydroxide, or you can say that a base. In this base, you have two parts. One is this part and second is this one. This is the positive part and this is the negative part. Here you have another thing, HCl. This is a molecule of hydrochloric acid. This is the positive part of, this is the negative part of this one. Till here, any question? Okay.
No.
How they react? This bond is broken down from here. And this bond is broken down here. Now this positive go toward this negative. And this negative go toward this positive. And then what they make? NaCl plus H2O. Here again, you can, this the positive, this the negative, and this hydrogen obviously positive and this the negative. Now come back towards your textbook. Look this one. Is it same as I explain you? H positive, Cl negative. Na positive, OH negative. So this negative with this positive and this positive with this negative. Sah wala la?
صح.
Now NaCl again, negative positive combine. Like these two combine and they make a salt. And when these two combine, they make water molecule. Yes. What's the problem in the equation? Maybe I gonna explain this equation more than 17 or 18 times to you. Yes?
No, sir.
Now I move next.
Yes.
Okay. Wallahi, tell me before. Maybe you say, sir, Mr. Come, go up again. See again carefully. No problem for me. Okay, my dear. Here we going to see from here. It's better to do this one. This one.
You finished the book, yes? You said you finished.
Yes, we finished today, inshallah. This all. Don't worry.
Okay.
Water of crystallization. This is a very important topic. Okay. Try to understand this one. What it means? Some salts, such as sodium chloride, yani NaCl, okay, just we done. Copper carbonate, you know very well, CuCO3, and sodium nitrate, NaNO3, crystallize in their anhydrous. What is the meaning of anhydrous? Anhydrous mean without water. Understand? Anhydrous mean without water. Don't forget this. He can ask you in the objective, yani MCQ question. However, many salts produce hydrates when they crystallize from solution. A hydrate is a salt which incorporate water into the crystal structure. What it mean? For example, you're going to prepare something. For example, you prepare a cake. The cake you make or bake, what do you think that there is water or no water in the cake? Yes. Hurry up.
No.
How no? There will be a water molecules. In the bread, there is water molecules. Till you burn it and you will evaporate all the water from it. Otherwise, there are
Yes,
water.
after I cook.
Yeah, after you cook. Very good. There is water molecules. Okay. If water is there, this is called hydrated. If without water, you can say that anhydrous. Look as it's mentioned here. Okay. This water is referred as water of crystallization. If during the formation of any crystal, water is there, this is called water of crystallization. Understand?
Yes.
Now, key definition, see this one. Mr. Amru, any question? Only this, what his name, speaking, Ahmad Musab.
Ahmed.
Yes. Amru, wallahi, you said 10 o'clock. If you sleep before 9:30, I will come to your home and wake you up. Can you explain again, but faster? Why faster? Take your time. Why you need faster? Okay, no problem. Look this one. What is the meaning of hydrated? Hydrated is one that is chemically combined with water. Or you can say that H2O water is present in this crystal. This is called hydrated. Anhydrated substances containing no water. If there is no water in them, we call this as anhydrous. Very easy and very simple. Now let's see this one. Here we're going to see an experiment in which you will see that how the change in water that occur and how we get a water molecule change the color, or you can say that the structure of the crystals. Here it shows you this the blue color. Okay, this one. Hydrate crystals left to right, cobalt nitrate, calcium nitrate, and nickel sulfate, and manganese sulfate, copper sulfate, and chromium potassium sulfate at the bottom. You will see here. When many hydrates are heated, what it say? What you going to do? You have a hydrate, mean to say you have a water in some crystals. What you gonna do? You heat them. You're going to increase their temperature. What happened? The water of crystallization is driven away. It's mean the water go out from the crystals. Okay, then what happened? For example, crystals of copper sulfate. If it is hydrated, yani if it is with water, it will color will be blue. Understand? He can ask you in the question,
Yes.
the hydrated crystals of copper sulfate, what was or what will be their colors? You will say simply it's blue. Are heated strongly, they lost their water. Okay, when you heat this, you give temperature, and what happened? The water go away from this crystal. Okay, H2O go out. Then what happened? Remaining white powder. Then these crystals of blue will convert into white powder. Till here, any question? Yes, please.
So, sir, after the crystals are heated strongly, after they lose their water, what will happen to it?
Then their color change. They from blue color to become white powder. They change their color, lose their color. Okay.
Okay.
Okay. Now look the chemical equation. This is the formula of copper sulfate, but look 5H2O with it, because that is a water molecule. Mean to say 5 water molecules are attached with it. Okay. Now what you going to do? You heat it. When you heat it, look, this water go out and this become anhydrous. Anhydrous mean without water. Yeah. Anhydrous mean
Without water.
without water. So when water go out from this crystal, it become white. It become white powder. Now, what you need to do now? If you want to get back the blue color, my dear, you simply add water in it. Okay, when water comes back, it again comes as hydrated, and this is called again back in blue color. You maybe hear about the crystals or the problem. Sometimes you say that the baby have loose motion or someone have vomiting. You say now go to the hospital, give him glucose or give him the drip, and he will take more water because due to motion and vomiting all his water go from his body, so it become anhydrous, or you can say that dehydrated. Okay, D mean if some word like D comes from any word, it's mean without. Dehydrated.
Yes.
Okay,
Okay, what
D
is the F and D?
same. N also means same like this. N mean also without. Okay, anhydrous
S
without water.
CuSO4S.
This copper sulfate, CuSO for copper sulfate. But if it's attached
Okay.
with water, it become copper sulfate as a chemical.
Yes.
Understand?
Okay, the S symbol, what does it mean?
Millions time Ahmad Musab, I told you. Look, S for solid, L for liquid, G for gas, and
Okay.
AQ mean aqueous. What do you want now?
Why do not erase it?
What?
Do not erase it. I'll write it so I will not forget it again. I'll never ask again about it.
No problem, no problem. You can ask millions time, no problem. But you need to remember also, okay? This is the simple things. I don't say you why you asking. I never make any problem to student to ask a question. But the problem is that you need to remember these things. Even if these are not a difficult thing. You can ask anytime anything. That's good. And Mr. Amro, you also. And don't say me, tell me, but it will be fast. Okay. I think Amro is enjoying the lesson. All right. Right done, my dear. Very nice. Good.
Yes, sir, I finished.
Okay. So till here, we understand two things. One is hydrated and second is anhydrated. Okay. So here it's give you some examples like the key definitions of couple of things you can easily see and you can do it very well. Now, this the last part here you can see as if no water, it can lose or change its color. If it become hydrated, you mean to say you'd add water, it again take its color back as blue. Okay. So this is all about the lessons that we learned. You know about the titration. I explained you in detail. Now, Mr. Ahmad, next you will tell me what we're going to do for the, what do you mean, the notes or the classified paper? It's up to you. You tell me, please.
Okay, can you